Okay, section 4.1, we're going to be talking about solving a system of equations. And the first method that we're going to talk about is solving by graphing. So when we're finding a solution to a system of equations, we're finding an x and a y that make both of the equations true. So if I plugged in this same x and y into both of the equations would equal the same thing on both sides. Okay, so graphing is probably the most ineffective method, but it is one of the methods, so we do have to talk about it, but it's very quick and easy. So what we're going to do in number one, you want to make sure, however method you're graphing, most of us will probably graph in y equals mx plus b, so let's make sure that our equations are set equal to y, which they are, and you're just literally going to graph both of those lines. So I'm going to graph this line in dark purple, and then I'm going to graph the second line in light purple. So for the first line, my starting point is -4. Someone told me this before, and I think it'll help you guys remember that our B is the beginning. That's where we start, right? And our M is how we move. So keep that in mind when you're graphing these if you're still kind of confused how to graph a line. So my beginning is -4. And I'm going to move 8 over 1. So I'm going to go up 8 to the right 1. And I'm going to connect my 2 points. And then for my second line, my beginning is +3. And when I'm graphing this line, I want to see where they're going to intersect. So I'm going to count my slope, so I'm going towards the other line. So I'm going to go up 1 over 1, right? That's my slope, 1. And when I connect these points, I could see that they intersect at this point right here. That means that that point is on both of these lines, which means the x and the y would make both of these equations true, so that would be my solution. So I just got to list what that point is. So the point is at 1, 4. So my solution would be 1, 4. And we're going to write our answers as ordered pairs. Okay, we're going to write our answers as ordered pairs. What this ordered pair is saying is that my x is equal to 1 and my y is equal to 4. So if I plugged in 1 for x and y for 4 for both of these equations, it would make both of the equations true. Okay, I'm going to do the same thing in number 2. So I'm going to graph this one in light purple. So my beginning is -5, which is right here, and my slope is 1 over 1. So what you have to be careful about is when you're doing these problems, you got to make sure you're extending your line as far as you can because you don't know where the lines are going to intersect. Okay, so I got to make my line as long as possible. And then for the second one, my beginning is at +7 and my slope is -1 over 1. So I'm going to keep going down and to the right until I intersect with the other line. So this is where I cross with the other line. That's my solution. The intersection point is always the solution, and that point is at 6, 1. So my solution is 6, 1. And again, what this is saying is x is equal to 6, y is equal to 1. So when you're finding solutions to systems, you're always finding an ordered pair. Okay, it's always got to be 2 answers. So for number 3, none of my equations are solved for y, so I'm going to solve both of these. So I need to get this 4x to the other side, so this becomes 3y equals -4x minus 9, and then I'm going to divide everything by 3. So my new equation is y equals -4/3 x minus 3. Okay, and then I'm going to solve the second equation, so I'm going to move this x over. I'm going to finish this over here. So -3y equals -x minus 6. And then I'm going to divide everything by -3. So y equals, remember there's an invisible 1 in front of that x, and those double negatives are going to make that positive. So it's +1/3 x plus 2. So I'm going to graph this light purple one first. My starting point is +2, and my slope is 1 over 3, so up 1 to the right 3, and remember we want our line to extend as far as it can go across the coordinate plane, so I'm going to go the other direction too, so down 1 to the left 3, and I'm going to connect my points. Okay, and then I'm going to do the same thing for the dark purple line, so I'm going to begin at -3, and my slope is -4/3. So instead of going down 4 to the left or to the right 3, I'm going to go up 4 to the left 3. I want to go towards that other line. So 1, 2, 3, 4 to the left 3. It's kind of perfect. It matches up right away. If I could connect my line. Sorry, guys. And so where they intersect, that is my answer. So that is at -3, 1. So x is equal to -3, y is equal to 1. Okay, I'm going to do the same thing with number 4. So I'm going to solve both of these equations for y. So this becomes -3y equals -5x plus 6. Divide everything by -3. So y equals positive 5/3 x minus 2. I'm going to do the same thing I did to the second equation. So I'm going to add 12. Let me move this over here. So that becomes -x plus 12 equals 3y. Now if this bugs you that the y is on the opposite side, you could flip the whole equation around. So I could just say this is 3y minus x plus 12. Okay, and then I'm going to divide everything by 3. So my equation is y equals -1/3 x plus 4. Okay, so I'm going to graph the light purple one first. I begin at +4, and I'm going to go up 1 to the left 3. Up 1 to the left 3, up 1 to the left 3, and I'm going to do the same thing in the other direction. Again, I want my points to extend all the way through the coordinate plane. 2, 3. Okay. Connect your points. I am so bad at this. Okay. Then I'm going to do the dark purple line. So it's begin at -2. My slope is 5/3. So I'm going to go up and to the right. So I go towards the other line. So 1, 2, 3, 4, 5. 1, 2, 3. There's my intersection point. So I'm just going to stop right there, connect my points. And that's my solution. So that is 3, 3. And then you're done. Okay. Now we have some special cases that happen. So same process. I'm going to solve both of these for y. So this becomes -y. I'm going to subtract the 10x, so that's -10x minus 8. Divide everything by -1. So y equals positive 10x plus 8. And then I'm going to solve the other equation. Let me move this over here. So 3y equals 30x plus 24. And then I'm going to divide everything by 3. So y equals 10x plus 8. Okay, so I'm going to graph that one first. So my starting point is 8. Obviously, I'm not going to go up 10 because that's going to take me way off the graph. So I'm going to go down 10 to the left 1. And then I can't go any further because if I go down 10 again, I'm going to go off the graph. So I'm going to connect these 2 points. And now I'm going to graph the dark purple one. So I'm going to begin at +8, go down. Notice these are the same exact line, right? These are intersecting the entire way. Now, usually when that happens, when we have the same equation, we would say all real numbers. However, it is different with a system of equations. I can't say my solution is all real numbers because let's say I picked a point right here. What is that? That's 6, 4. If I plug that into one of my equations, let's I mean, they're both the same. So if I plugged it into the equation, so 4 equals 10 times 6 plus 8, that gives me 4 equals 68, which is not true. So this point right here is not a solution to my system. So I can't say all real numbers because not every single number works. So instead, since they're intersecting the whole line, and lines go on forever and ever and ever and ever, I'm going to say that this is an infinite amount of solutions. Because all of the points that are on this line are going to be a solution. They're going to work for both equations because the equations are exactly the same, but not every single point works. So we just have to say infinite in this situation. Okay, and number 6, I'm going to do the same thing. I'm going to get y by itself, so I'm going to add 2 and subtract x at the same time. So my equation becomes y equals negative x plus 2. Make sure we're keeping it in order. Y equals then our x, then our number. I'm going to do the same thing over here. So I'm going to subtract by 3. So I get negative 3x minus 3 equals 3y. Again, if you want to flip this around, you can. So 3y equals negative 3x minus 3. Divide everything by 3. So y equals negative x minus 1. Okay, so I'm going to graph the light purple line first. So my starting point is negative 1, and my slope is negative 1. Oop, going the wrong way. So I'm going to go up 1 to the left 1. So my points are going to go all the way through. And then I'm going to graph the dark purple line. So my starting point is 2. My slope is negative 1. Okay, connect your points. Oop. Why is this not working for me? Okay, so notice these are parallel lines, right? These are not going to intersect, right? Parallel lines mean lines that never, ever, ever cross. Well, when we're solving a system of equations by graphing, we're looking for the intersection point. So if there is no intersection point, there isn't going to be a solution. There's never going to be an x and y that's going to make both of these equations true. Okay, so no solution. So let me summarize this. Same line, like in the first example right here. If they're the same line, it's going to be infinite. Okay, if it's a parallel line, so they have the same slopes, it's going to be no solution. Okay, so you have to be careful though. Some people will look at number 5 and be like, oh, those have the same slopes. That's going to be no solution. However, they're the same exact line. Okay, they have the same y-intercept, so that's going to be infinite. When you have parallel lines, you have the same slope, but you have different y-intercepts. That's how I know they're never going to intersect. So if you notice that right away, you don't even have to graph those. I'm okay with you being like, oh, those are 2 different y-intercepts, but it's the same slope. They're never going to cross. That's no solution. Or you could look at number 5 and be like, oh, okay, those are the same exact equations. That's got to be infinite solutions.